Good evening, Sarah. Today is January 14th. It is 5:30 p.m. and I noticed you didn't do a video yesterday. There's absolutely no problem. You were busy and you had Tai Chi. But as such, I figured a good payback would be to give you a video on physics, your favorite science. So let's talk about electric charge. Suppose there's two opposite charges, A and B. Obviously, with two opposite charges, they will attract. So you'll end up seeing a force act on one charge towards the other. If they were two similar charges, a force would repel the charge away from each other. This would work with just two charges or billions and billions more. Thanks to Newtonian physics, this is a pretty simple concept. The same concept applies for gravity. If you have a mass at a certain height above the Earth, a force will act on it towards the ground. But then physicists began to ask the question of how quickly this force acts on the object or charge. For example, if charge B was attracted towards A, and A moved 3 micrometers away in a nanosecond, how quickly would that force change direction? According to Isaac Newton and Charles Coulomb, they would have said it reacted instantly. But what if charge A was 30 million kilometers away? Surely the force on B wouldn't be instantaneous. Along comes Michael Faraday, born in the impoverished society of London. He was self-taught and an excellent experimental chemist and physicist. But since he didn't have any math background, he excelled more at conceptual reasoning rather than quantitative measurement. He suggested that rather than charge A producing a force on charge B, charge A produced a field in space that produced a force on B. In that sense, charge A affects its surroundings so that when anything is in that space, depending on how far away it is, the electric field A produces will affect that other charge. For example, if A is positive, it will produce an electric field that repels all other positive charges and attracts all negative charges towards charge A. And the closer that other charge is, the stronger that force will be. The same works for gravity. No matter where you are, there is a constant field produced by Earth that is pulling you and your surroundings toward it. So next time you see someone saying that a proton pulls an electron towards it, or that Earth produces a force on an apple to fall from a tree, realize it's a little more complicated than that. I love you very much, and I will see you tomorrow.